Hi, in this video we are going to talk about tree data structure. Consider a problem where you need to represent hierarchy. For example, organization structure. You want to represent organization structure using a data structure in memory. You have CEO at the top, then you have COO, CTO reporting to him, and then people reporting to these guys, CTO and COO. Another example of hierarchy, folder structure. You have root folder structure, then there are subfolders that this folder has, and these subfolders have their own subfolders. How will you represent these things using a data structure? We have talked about different data structures before tree. We have talked about arrays, linked list, stack, queue. We cannot use any of the previous data structures to represent hierarchy because these previous data structures, they were all linear. They traverse from one side to other side and they do insert and deletion in a linear fashion. Tree is a non-linear data structure. If you compare tree with the previous data structures, all the previous data structures, they store the data in sequential fashion. Tree stores the data in hierarchical fashion. All the items that we see in this tree, they are called nodes of the tree. And at the top of the hierarchy, we have root node. This particular node, which is at the top of the hierarchy, is called root. And the nodes which are at the bottom of the hierarchy, the nodes which do not have anything below them, they are called leaf nodes. So this is a leaf node because there is nothing below it. This is also leaf, this is also leaf, this is also leaf, and these two are also leaf nodes. Nodes which are just below a node are called children of this node. For example, 30 has 3 children, 8, 30 and 80. And this 30 has 2 children, 70 and 9. This has 2 children, 40 and 5. Node which is just above a node is called parent of this node. Parent of 5 is 20. Parent of 8 is 30. Parent of 80 is also 30. Tree data structure is recursive in nature. You can notice that the left side of this root is also a tree. And this tree has root 20. The right side is also a tree and this has root 30. So a tree itself contains many trees inside it and these are called subtrees of this tree. This is a subtree of this tree with 20 as root. This is a subtree of this tree with 30 as root. This is also a subtree with 30 as root. Let us now talk about descendants and ancestors. Descendants of a node are all the nodes that lie in the subtree with this particular node as root. For example, if I want to know the descendants of 20, I'll consider the subtree with 20 as root. And 40 and 5 are the two nodes that lie in this subtree. So these two are descendant of 20. Now if I want to know the descendants of 10, everything lies in the subtree rooted with 10 because 10 is root of this tree. So all the other nodes, they are descendants of 10. Degree of a node. Degree of a node is the number of children it has. So degree of 10 is 2. Degree of 30 is 3 because it has 3 children. Degree of 30 is 2. And you can notice that all the leaf nodes, they have degree 0. So you can define leaf node this way, that the nodes which have degree 0 are called leaf nodes. And all the other nodes which are not leaf nodes, they are called internal nodes. So there is one more term, internal node in trees. The trees which do not have degree 0 or which are not leaves are called internal nodes. So internal nodes in this tree are 20, this 30 and 10. These are all internal nodes in this given tree. In this video, we have introduced tree data structure. We have talked about different terminologies related to tree data structure. In the next video, we are going to talk about binary tree data structure and its representation.